In this video, we're going to look at how to solve the following higher order equations that can be reduced to a quadratic equation. For our first example, we're going to be solving the equation x to the 6 minus 26x cubed minus 27 is equal to 0. This equation is of degree 6 because the highest power of x is equal to 6. We can reduce this to a quadratic equation by recognizing that this term x to the 6 can also be rewritten as x cubed or squared using the index law. Using this trick, we can now rewrite this entire equation as x cubed or squared minus 26x cubed minus 27 is equal to 0. Our next step is to introduce the variable u. We're going to say let u equal to x cubed, and we're going to replace all these x cubed terms with u so that we have a quadratic equation in terms of u, which is u squared minus 26u minus 27 is equal to 0. This is a monic quadratic, and to solve this quadratic, we can use the PSF method, which stands for product, sum, and factors. To use the PSF method, we need to look for two numbers, a and b, that multiplies to give the constant, which is negative 27. The same two numbers a and b also needs to add to give the coefficient of u, which is negative 26. The two numbers that would satisfy both of these conditions would be if a is equal to 1 and if b is equal to negative 27, because 1 times negative 27 gives us negative 27 and 1 plus negative 27 gives us negative 26. Once we have these factors a and b, we can now factorize this quadratic equation into u plus 1 times u minus 27 is equal to 0. Now, to solve this, we use the null factor law, which says that if two factors multiply to give 0, either one of them is 0 or both of them is 0. So we can have either u plus 1 is equal to 0 or u minus 27 is equal to 0. If u plus 1 is equal to 0, we're going to replace the u with our definition, x cubed, so that we get x cubed plus 1 is equal to 0. Then to solve for x, we simply subtract 1 from both sides and then taking the cube root. And this is going to give us the solution x is equal to negative 1. If u minus 27 is equal to 0, again, we replace the u with x cubed, so we get x cubed minus 27 is equal to 0. We add 27 to both sides, and then to solve for x, we take the cube root of both sides so that we get x is equal to 3. So for this degree 6 equation, we actually have two solutions only, which are x is equal to negative 1 and x is equal to 3. So why do we get two solutions for this equation of degree 6? Well, anytime we solve an equation like this, we're essentially solving simultaneous equations. In this case, we are solving the simultaneous equation between y is equal to x to the 6 minus 26x cubed minus 27 and the equation y is equal to 0, which is essentially the x-axis. The solutions to our simultaneous equations correspond to the points of intersection of the two graphs. So if we look at the graphs of both of these graphs, we see that the graph y is equal to x to the 6 minus 26x cubed minus 27 intersects the x-axis, y is equal to 0 at 2 points. First is at x is equal to negative 1 and another point is x is equal to 3. And both of these values correspond to the solutions we found on the previous slide. For our second example, we're going to solve 2x minus 7 times the square root of x minus 15 is equal to 0. To solve this equation, we want to recognize that this term x can be rewritten as the square root of x or squared. Remember, the square root and the square are inverse operations of each other and will cancel out to leave us with just x. Using this trick, we can now rewrite this entire equation as 2 times the square root of x all squared minus 7 times the square root of x minus 15 is equal to 0. Next, we're going to introduce the variable u. We're going to say let u equal to the positive square root of x. And note here how I explicitly stated that it is the positive square root of x. And you'll see why this is important later on. So we now are going to replace all these root x terms with the variable u to get a quadratic equation. 2u squared minus 7u minus 15 is equal to 0. This quadratic equation is a non-monoquadratic equation because the coefficient of u squared is 2 and not 1. We can still use the PSF method to help us factorize this expression. To use the PSF method, we need to look for two numbers a and b that multiplies to give the product of the coefficient of u squared and the constant, which in this case is 2 times negative 15 or negative 30. The two numbers a and b also needs to add to give the coefficient of u, which is negative 7. The two numbers that would satisfy these conditions would be if a is equal to 3 and if b is equal to negative 10. Since 3 times negative 10 is going to give us negative 30, and 3 plus negative 10 is going to give us negative 7. After we've got these factors, we can rewrite this quadratic expression as 2u squared minus 10u plus 3u minus 15 is equal to 0. Notice how we've used these factors 3 and minus 7 to break up the minus 7u into two terms. Our next step now is to factorize this quadratic expression, and we're going to do that by using grouping in pairs. So if we look at the first pair, 2u squared minus 10u, it has got 2u as the common factor, so we can take out the 2u and get 2u times u minus 5. The second pair, 3u take away 15, has got positive 3 as a common factor, so we can take out the positive 3 and get plus 3 times u minus 5, and all of this is equal to 0. You see now that we've got u minus 5 as the common binomial factor. This expression now reduces to 2u plus 3 times u minus 5 is equal to 0. Now, for this equation to be 0, we again use the null factor law. We can have either 2u plus 3 is equal to 0 or u minus 5 is equal to 0. If 2u plus 3 is equal to 0, this would mean that u is equal to minus 3 on 2. We then use our definition, u is equal to positive square root x, so that we get positive square root x is equal to negative 3 on 2. But hold on, we started off by defining u as the positive square root x. So that means that we cannot have a negative solution. So for this equation, 2u plus 3 is equal to 0, we actually have got no real solution. So let's consider the other equation, u minus 5 is equal to 0. If u minus 5 is equal to 0, this means that u would be equal to 5. So again, making the substitution, u is equal to positive square root x is equal to 5. Now this is valid, and what we do is we square both sides in order to get rid of the square root, and we get the solution x is equal to 25. Let's now try to understand our solutions with graphs. In this equation, we have got a square root x term. This means that there is a restriction on the value of x, where x has got to be greater than or equal to 0. And remember, the solutions to this equation is essentially the points of intersection of the simultaneous equations below. So if we look at the graphs of the two functions, you can see that this blue graph intersects y is equal to 0 or the x-axis at one point where x is equal to 25, and the graph is only defined for x is greater than or equal to 0, and this point of intersection 25 actually corresponds to the solution that we just found. Thanks everyone for watching the video. I hope you guys found it useful. For more videos on this topic or other topics, please have a look at our channel. We do release videos weekly across various topics. So if you haven't already, don't forget to subscribe. We would love to see you guys all in the next one. Bye for now.